Hello. Thank you for joining me in this session. My name is Neciu, and I am here to talk to you about modern testing practices in web applications. Let me start the slide. Perfect. So, testing web applications is very, very easy. Said no one ever. And the reason we're no longer saying this is because the web has evolved from being a series of links, articles, basically static content, to the amazing web experience that we have today. To give you an example, the James Webb Space Telescope that takes amazing, never before seen pictures of the universe has a UI that runs JavaScript. Another example is the SpaceX Dragon crew that takes astronauts from Earth and delivers them to the International Space Station, has a UI and a control system that runs on Chromium and JavaScript. So the web is no longer used just for static content, but now it evolved in something very grand, and testing has to evolve alongside with it. The main reason being because now if something goes wrong, companies are going to lose millions of dollars, and even it can endanger human life. So let me begin by telling you a story. I work for Glovo. We're a food delivery company we operate in 25 countries, very similar to eFood. I think we have the same parent company. It was founded 8 years ago in Barcelona, and we have a suite of web applications. We have apps for couriers that deliver food. We have apps for our partners that input their catalogs. We have an admin that handles orders, and customer applications. And zooming in on the customer applications, we have one for iOS, one for Android, and of course, one for app. All three of them use the same API, and together they bring in about 20 million orders. Working on all of these projects, we are around 600 engineers. And what I found very surprising about this is out of 500 engineers, we have absolutely no QA. And for me, this was very, very surprising because I came from a company that had 2 or 3 QA engineers in the team that handled manual testing, automated testing, performance testing, and all sorts of work that made sure that what reaches production is bulletproof. And here we didn't have that. So when I joined the company, I asked my onboarding buddy, hey, how are we going to do this? What is the procedure? And she told me, hey, you have to follow the old testing pyramid. Unit test at the bottom, integration test at the top, and system tests at the highest peak. And you have to write a lot of unit tests for your feature, write a couple of integration tests and an end-to-end test if it's needed, and then manually test your feature. And I was like, manually test my feature? I mean, we developers are not that really good at this sort of thing. We're lazy. We have not that much attention to details that a QA or a designer or even a product manager has. But I was in the beginning of my journey, and I wasn't gonna ruffle any feathers right now. So in my beginning task, the task for my onboarding, I was supposed to change something or other in the sign-up dialog, which was a pretty important dialog to work on. And I did it. I wrote some unit tests for my feature. I wrote an end-to-end test. Of course, I manually tested my feature, as we all do. And everything went fine, except that I broke the CSS of all the dialogues in the application. All of them, except one, the one that I was working on. The sign-up dialog was fine. The other 46 other dialogues were a mess. All the CSS was gone from them. And back then, we didn't have continuous integration. We didn't have continuous delivery. We had release trains every 2 weeks. So the broken CSS had to stay that way in production for 2 weeks. And I was so ashamed. Every time I walked in the office, I wasn't looking people in the eye. It was a complete mess. And we realized back then, this was 2 or 3 years ago, that this cannot go on. Like we have to have better practices in place to make sure this doesn't happen. So we realized that the old school testing pyramid was not working. It was comparing speed. It was saying back then that, hey, unit tests are faster to run than end-to-end tests. It was comparing costs. It was saying like it's cheaper for developers and faster to write unit tests than end-to-end tests. But it was not comparing confidence. It was not caring that we as developers are more confident in end-to-end tests than we are in unit tests. And of course, there are a lot of testing structure out there, like the testing trophy, the testing obelisk, that more or less are saying the same thing I'm going to present today. But I wanted to create my own testing structure just because it's cool, right? So this is the testing wormhole. And the reason I decided to use a wormhole is because it's in space. A wormhole is in space. It has no left, right, up, and down. So in space, as you know, nobody can hear you scream your frustration because your end-to-end tests are not passing. It also has no left and right. So there's no important part at the bottom or at the middle or at the top. Everything is as important as the rest. So for today, I'm going to talk about 3 main points of the testing wormhole. And these are the lazy tests that you need to integrate into your CI/CD pipeline, unit tests and how to make sure they're good at their job, and feature tests for the front-end application. We're going to start with lazy tests. And when I say lazy, I mean that, you code it and you forget about it. You at the beginning of the project, or you keep adding them, but you don't have to maintain them. It's not for every new feature you have to add something new. No, it's there and it's good for your entire project. So a good thing to automate this is to use automated commits. So we use a third-party library called Husky, which is on top of GitHub hooks, and it makes sure for every commit you do into your branch, it runs whatever you want it to run. For example, a linter, or to make sure that prettier is running in your application, and to make sure you don't have typos or that you're following standards. And this one is a really big, important part for us, the ES rules, because we are like 60 or 70 engineers that are working on the same code base, and we have to make sure that we are following the same standards. We want to make sure that we're not importing files directly. We want to have an index file that exports everything, so every component is modularized. And this will pave the future if we want to go to the micro frontends route in the future. Naming conventions, file folder conventions, where to use Vuex and where to not, when to use CSS, because we have a design system and we don't want to use colors randomly in the application. We want to use just what we have in the design system, and this helps us a lot. We can also enforce accessibility rules. We can create our own rules on top of the rules that are coming from the Nuxt application, because we're using Nuxt in frontend with Vue. And another thing that you can check at commit level is the performance of your application. So as you know, Google has started ranking your apps by these 3 metrics, which are LCP, FID, and CLS. And based on the performance of these, it will rank your application in your SEO, basically in google.com. So, and this makes sense, right? There's a clear correlation between CFR, conversion rate, and performance. If a website puts faster, a user will probably interact with it more and order more or faster than other types of applications that load slower. And there are a lot of articles out there that show you that for each 100th of a milliseconds, your conversion rate drops. And there are a lot of tools to measure performance. You have Lighthouse, you have webpagetest.org. You have Google Search Console, you have the Crux report, again from Google, and you have real user monitoring tools like Datadog and Sentry that provide a lot of functionality. But for us, we realized that the two biggest important tools that we use to fix performance and measure it is Google Search Console and webpagetest.org. Google Search Console will rank your URLs and deep dive and tell you a group and what's wrong with them. And you can use web page test to zoom in on the problem and see where you can improve it. But this is not all. Like, you have Lighthouse in your browser, but keep in mind that Lighthouse in the browser will be as fast as your machine. So for developers who have new MacBooks, M2s and 1s, normally every website is going to be fast. And you can throttle and do stuff, but it doesn't tell you what real users are suffering. But Lighthouse also has a quick a library to integrate into your CI pipeline. So these are the tests that you need to have to make sure that you're not degrading your performance metrics. And Lighthouse has 3 pillars of how much you know about performance, about CI. So you can just implement the basic necessities, you can implement more if you know more, and you can implement as much as possible as you learn with the library. And in the end, you'll have this in your GitHub Actions, your application. Can check performance, it can check accessibility, it can be split by routes. And to write a performance test is, like I said, very lazy and very easy to do. You just give it an option, pages, and some thresholds, and you say, hey, Cypress, use Lighthouse library and measure this. And then you get, based on your threshold, if it failed or not. And of course, one thing that matters the most about performance is the size of the application. So you don't want to give to a user megabytes and megabytes of JavaScript. And what we did to make sure that we are taking care of not adding third-party libraries or coding duplicate code and bloating the application with a lot of useless code is we have this BundleLemon third library that checks at each PR that we didn't pass our set thresholds. So we have a max size of 2 kilobytes for a file. If somehow your application suppresses that, the PR will fail and you're not going to be allowed to merge into master. A really cool feature about BundleLemon is it's a wrapper around bundle size that also lets you check for max increase percentage-wise. Sometimes it's not enough just to have a hard limit, because as you know, people are adding code, removing code, and this kind of goes up and down, but you don't want people to add more than a limit. So if someone before has just deleted a bunch of code, you want to make sure that this PR here only increases in percentage-wise and not a hard limit. So in conclusion, keep your bundle small, use linter rules to enforce best practices. An increase in performance can significantly affect conversion rate, and Google is your friend. They have a lot of tools available that you can integrate into your application and use for measuring your website. And there are RUM, real user monitoring tools like Datadog and Sentry that help you measure everything. So observability is key. Let's move on to unit tests on steroids. So as we know, unit tests are like the below pillar of the testing pyramid. The general consensus is to write millions of them as much as possible because they're cheap and they're fast. And they help you to keep the integrity of your application. And if someone doesn't know what a unit test is, basically, if you have a function that takes 2 parameters, like here, we have a sum function, takes A and B, and returns the sum of that. A unit test normally would be to import that sum function, give it 1 and 1, and expect the result to be 2. And then you can write another unit test to test the boundary situation. Like you can give it -1 and -1 and expect the results to be -2. You can even go a step further and check for error cases, right? You add it, give him, instead of two numbers, you give it two strings. So here we give it a T-Rex and a shark, and we would expect the result to be some sort of error, obviously. And in theory, this is very, very good. Like, it's perfect, and it's very good for utility functions from helpers, mutations, API responses, basically pure functions and pure JavaScript. But 90% of our application is not that. We usually use a framework, and we have something like components. This is like a normal view component that we have in our application. It's a counter component. It has a plus and a minus button, and it just shows the result. So when you have these sort of things, the first thing you should be looking at is, what do I test here? What is unit testable? And the first thing you should do is look at your component and ask, does this part actually need to be a part of this component? Or is it a separate unit system pure function that can be extracted and tested in isolation? So for example, here in our counter, we have these two functions that can very easily be extracted into helpers and reused in other parts of the application. And by extracting it in a pure function and not having it dependent on the framework, you can test it very easily in isolation. You just import it. You can run it with one value, with two, with three, create as many use cases as you need necessary. You can check what happens if you have already set the max value and you go over it. What's the default value, so forth and so forth. There are no limits. But one problem you have with unit tests, okay, you've written a million of them, you have them in your applications, but how do you know they're actually good? How do you know they're bringing value to your code and are not just passing as by mistake? What if they're false positives? You have a million unit tests. You cannot go one by one and check them. So what you have to do is, for example, a clear example, you have a sum, it returns A plus B, and by mistake, we are returning 2. Of course, the unit test that we wrote that expects 2 is gonna pass, is gonna be green. So this is a false positive. And the solution for this is mutation testing. Mutation testing is kind of a change in mentality that you need to do, because it doesn't test that your code is working. It's actually testing that your code is failing when it should fail. So what it does, if your code is a very simple pure function, the mutation mutation library is gonna go into your function, find out when it's gonna see a plus or minus or a return statement or something, and just change it a little bit. So now it has created a mutation of your code, and it's going to run the tests. And then it's going to go a little bit further and change it again. And it's going to change it as much as possible until sometimes you're not even going to recognize your function to the one in the beginning. But it's going to continuously run your tests, and it's expecting them to fail. If a test survives with that many changes and more changes, then that means that you have flaky tests and false positives. So it's going to put out a report that here are your tests that didn't make the cut, and you have to go through them one by one and make them better. To give an example of our sum function, here is the test that expects the result to be 2. It's just going to modify that plus into a minus. And of course, it's going to fail the test. So this function and this unit test is good. In conclusion, apply these practices to increase confidence in your tests and your unit tests. Mutations can be async. You can separate logic from UI. Test results and not implementation. Do not import directly from the component the functions and test them. Try to test that what the user sees is actually testable. Keep the test compact and readable. And if it's difficult to set up a unit test, maybe it's better to rethink the design. So, okay, you have really strong unit tests. You have a million of them. they're working great, there are no false positives, but that doesn't mean it's actually what the user expects. We've all seen the memes where the designer designs something, the developer builds it, and the user use it completely different. So this is exactly what you should do. You should have tests that test real user behavior. So these are the feature tests from the front end. And together they bring in the last two parts of the testing pyramid. So usually they're integration tests and system tests. I'm going to start with a concept called visual testing, which can be integrated with your CI/CD pipeline. And basically, to set them up, they're sort of like lazy tests that you only write them once, but you have to add more visual tests as you improve your features, and you have to interact with them a little bit. They're very easy to write. Before, if you had to write an end-to-end test, you had like 20 commands. A visual test is just one simple command that says, go to this page, check the login page. And the library is going to go to that page and it's going to take a photo, basically a screenshot of your page. And for each branch and feature you build, it's going to compare with the master and analyze it if it's good or not, what changed. And it's going to ask you, is this change intentional or not? If it's not, it's going to break the pipeline. And it's going to tell you what has changed, not that just there are changes. So for example, some icons are missing, some buttons are not aligned as they used to be. Some text is disappearing. And all of this is handled by the library. And you can see what errors and where they are happening. And if you have this in place, all your new joiners won't be breaking dialogs anymore like I did in my first day. So it's very critical for CSS and image, and if you have a lot of CSS heavy websites, to have visual tests in place, because CSS bugs are very common, and there are a lot of scary stories where people have lost money just because a button was appearing to be disabled and people were not clicking on it. So make sure this does not happen to you. One problem with visual tests, though, is that you cannot actually interact with them. They're good for taking a screenshot, but if you have to scroll or navigate between pages, they're not very good. They have a lot of problems. So for that, we have like component testing. And component testing is sort of an integration test or a combination with a unit test, but it just takes a component or a multiple of components and boots up a browser, an application with just your component in it. So coming back to our counter function that before, it will just take this component and it's gonna show it to you in a browser. And you can write unit tests like an actual user would. You can interact with it using area labels, using whatever you want, classes, IDs. You can actually query the elements by the text inside them. So this is what an actual user would do. It will see a button that says, click me, and it will click that button. And you can use that in your tests. And you can mount this component as different as you like, with different parameters, different props, and then interact with it as a user would. So get the selector, click it, and see the result. Because an important part of this is to test the result of your component. So when you're interacting with it, what happens? What's changing? Should I make sure that this corresponds to the expected result? So if I click an increment selector, I'm expecting the text to be 1 if the default was 0. If I'm decrementing, I'm expected to be back to 0. So these are integration tests with, you can use Cypress, you can use different libraries like Playwright. All of them have the same functionality, more or less. What's good about them is they're using a real browser. So they don't run in a terminal like integration test, and you can see the result. They're very good for development environment. So if you have an application that's very heavy, and you're working on a component, you don't want to boot the entire application, go to the specific page and code and see the results, because maybe your laptop is going to go on fire, or development environments are usually heavy. So this is good because you're just booting what you're working on at the moment, and you can code in peace. And you're testing like a real user. And speaking about real users, a common test to make sure to test user journeys are end-to-end tests. And end-to-end tests are a little problematic, let's say, but the basic gist of them are they follow a user journey from the beginning to an end, and they interact with page just like a user would. But the problem with them that are pretty common in a lot of companies is that they're slow. You have to wait for API responses, and API responses may change. They're very flaky. It's hard to coordinate between front-end and back-end to set up a correct end-to-end testing environment with different branches. And it's a lot. You're also testing a lot of duplications. So for example, if you have a website, an e-commerce website, and you have an end-to-end test that checks from the catalog to the checkout, in the middle, you may have to log in or add an address or something like that. And when you're doing the same thing from the product page, again, you have to log in. So this login functionality is duplicated. And for us, how we manage to solve it is by mocking absolutely everything. And I know this is a little bit controversial. Are they actually end-to-end tests if we're mocking the entire backend? And for us, we saw that it decreased a lot of developer frustrations and a lot of bugs. So what we're doing is we're mocking the API completely, but we have contract testing in place to make sure that the API does not change with our mocks, their one-to-one values. We're running our end-to-end tests in parallel. That way they're no longer slow. And we're implementing skip and mock functionalities to make sure we're not retesting everything over and over again and making them shorter and faster. So how do we mock the API? Basically, we have a mock server in our application, a node server. And this node server is basically a proxy. For each request we make to it goes to the API server, and it mocks the response in a JSON file. And next time we're running them, instead of going to the server, it returns the JSON files that we have saved. And it doesn't allow you to make requests that are not mocked. If you're adding a new feature and you're making a new request, every time you have to first record the response and then run your unit test, end-to-end test, and write them. We have contract testing in place, like I said, so the API doesn't change. And how this works is us, the front-end application, we are the consumer. So we set up a contract and we say for each request that we make to the backend, we are expecting this to be this key, this value. We want this to be a Boolean, this to be an array. We expect this TypeScript object, and we can make it as complex as and easy as possible. And this is saved in the contract library. For example, we are using Pact, and every time the backend has a new PR, it's going to verify the responses with our contract and will not allow it to change anything that's going on, because it will break the front-end application. And it's just not us. We have three, like I said, customer applications, and all three of them have contracts in place because the backend is using values differently, and we want to make sure everything stays aligned. Using GitHub Actions, we are splitting in the build process our end-to-end tests, not only by file, you can have multiple end-to-end tests in multiple files, but we are also breaking them by describe test suites. So each describe is broken into its own file, and this is part of the building process, and then it's run into the GitHub Actions, so we can run them in parallel. By having them in parallel, before it used to take us an hour to run 50 or 60 end-to-end tests. Now we just have to wait 10 minutes for the longest to finish wrapping up. We're also using a parallelization orchestrator. So in case one end-to-end test is failing, all of them are stopped and skipped, so we don't waste resources and we get feedback to the developer as soon as possible. And mocking the skip functionality, like I said, if you had a flow from the homepage to the checkout, in the middle you may add an address and login. From the product page, you can go to another product page to a checkout. These are usual end-to-end test flows. And you have this login functionality that's everywhere. And of course, you can extract it in a command in the testing library, but you're still wasting 10 seconds, 20 seconds logging in each end-to-end test. And this, if it works once, for sure it's going to work in all of your cases. So you can test it in isolation as a component test, and then as a small isolated end-to-end test to make sure that the login is working, and then just keeping it in the entire in the rest of the end-to-end test. And how we're skipping it is we have two ways. We're either using a flag in development mode, so URL parameter that says user logged in equals true, and in the code we have this verification and we skip it completely. We assume that the user is logged in, or we're taking advantage of cookies. Cypress has this option to mock everything. So go to a URL with these cookies already in place, and it can simulate this behavior for you. So in conclusion, CSS and design matter. Have checks in place like visual checks to make sure the CSS is not breaking. Use component testing like a user in a real browser. Test result and not implementation. End-to-end tests are flaky, but they give you the most confidence in your application. So you have to have a strong process and a strong platform to help you with them. And don't duplicate tests for general functionality like login. Parallelize test in your CI/CD pipeline. For us now, the end-to-ends are faster than the actual unit tests. We have like 12,000 unit tests that take about 30 minutes. And now we've started parallelizing unit tests as well, breaking them into chunks so we can work even faster. And testing web apps is easy. I hope at least some of you who have attended this talk is going to say this afterwards. My name is Neciu. I'm a software engineer at Glovo. I like to write tech talk articles mostly about testing and CI/CD. Follow me on Twitter if you want to read more of what I have to say. I've worked on all big 3 JS frameworks, and I have a cat and one Greek friend that I work with. So thank you. I'm gonna go now and look at the Q&A to see if I have any questions. I think we have 7 minutes more. But if I need to, I'm gonna stop sharing. QA, no open questions. Cool. Well, thank you for joining me, and I hope you enjoy my presentation. If you have any questions or if you want to see the slides, reach out to me on Twitter, and have an amazing rest of the day. Thank you. Have a good day.